Okay, as you start finishing up writing down the theorems that you're going to need, the focus on this chapter with theorems is not for... There are proofs all throughout the book. That's not our purpose in this one. They exist, so you can see that it still follows that same kind of argument pattern. You can even see on 332 that there's a proof that uses triangle congruence theorems. We don't necessarily have time to do all of that, but what we focus on is each one of these shapes we're going to learn about are going to have some kind of rules that's going to help us set up maybe an algebra problem. And so there's going to be a lot. And so that's what we're trying to focus on with these theorems is the rules to help us set up maybe an algebra problem to set something else up. And so the first couple things that we need to know is, first of all, parallelogram is a quadrilateral, which means a four-sided shape. And the definition is real important because if the shape does not meet the definition, you can't use any of the rules. It is a quadrilateral with two pairs of parallel sides. And probably it should be two pairs of opposite parallel sides, which I guess it would have to be opposite. But it can't have one pair and work. It has to have two pairs. Okay? If that is the case, if it meets the definition of a parallelogram, then you can do the rest of what this is saying. So, and you learned this probably back in grade school, that opposite sides of a parallelogram are congruent. Okay? Opposite angles are congruent. Okay? Those are the first two theorems. You probably knew that already. You probably done that before. You just didn't call them theorems, and you didn't really focus on algebraic. And it even looks kind of the same, doesn't it? That looks obtuse, that looks obtuse, that looks acute. Probably the same. Going down to 7.5 and 7.6, those are things that you might not have done before. Okay. So just using this one right here, I'm going to call this angle 1. I'm going to call this angle 2. Just using those two, basically what theorem 7.5 says is that if I add, I don't know why I put the angle. You don't have to do that. I just have to put 1 and 2. If you add angle 1 and angle 2, it's going to equal 180. Okay? So again, we have that same kind of deal with the parallel lines that we had before, where opposite is going to equal each other. And, you know, didn't we do, with parallel lines, this was called what? Alternate interior angles? Are these alternate interior angles?
No.
They would be alternate interior angles, right? Because this is parallel, and that's a transversal. So those are consecutive interior angles, which equal 180. Okay, does that make sense? So we just expanded on that a little bit. Okay, and the biggest one that you probably don't know, and this is probably the biggest difference, is the diagonal theorems. I don't know how parallelogram this is going to look. Well, that's not very good. So the biggest difference on here is these bisect each other. So that means this equals this, and this equals this. And so we're going to use the word bisect again. So we're going to continue using the same things just in a different way. All right, so that's the basics behind this. And like I said, we're going to really focus on algebra stuff. And so look on page 336, and we're going to explain how things are done. Okay, we're basically going to look at shapes 3 through 6. I don't think are very hard. I want you to figure that out. I don't want to spoil any of these for you. And if you were worried about it, you just look at example 1 and it probably tells you how to do it. We're just going to use those first 2 theorems to kind of figure out what x is, what y is, based on that. Okay, moving down to 9. This is a little bit more complicated, where you got to figure out what is LM, what is LP. Okay, using those various rules, and I don't really want to help you very much on this. And then moving on to 17, 18, we're going to use those same rules. 19, 20, we're going to use the diagonal rules. Your goal is to set up algebra problems for almost every single one of these. But again, like 9 through 16, it's not really an algebra problem. You don't see it. It's not really an algebra problem because you're just supposed to fill in whatever they want by using the information given. Okay, you might have to add some numbers. You might have to, add some numbers and equal 180, something like that. But try to use those 4 rules and only those 4 rules to do those. Okay? And so let's go ahead and get through those so we can take notes on something else. We're going to do 3 through 22.